right, so partial fraction decomposition, this is video 3. What happens when we end up with something quadratic, a factor that is quadratic in the denominator? And what we end up with is we end up with a linear numerator, something in the form like bx plus c or ax plus b or something like that. So we started this one in video 1 when we were breaking into how many fractions this breaks into. So I'm going to start by factoring the denominator, and I see there's a 2x in common, so this is 2x times x squared plus 4. And what we talked about here is if I have a quadratic factor in the denominator, in other words, without this power, you have something squared within your family, you need to rewrite this. Well, I'm just going to take care of it's going to be just a number over 2x plus a linear numerator of bx plus c over x squared plus 4. This family. All right? So let's kind of take it from here, and we're going to have just a little bit of a different strategy for this one. So if I multiply everything through by the common denominator, so that's the common denominator, or think of clearing the fractions, 2x times x squared plus 4, 2x times x squared plus 4, and then multiply this by 2x times x squared plus 4. Here's what happens. We get x minus 6 equals a times x squared plus 4 plus, those cancel, bx plus c times 2x. Notice I put that numerator in parentheses. That's a whole expression that needs to be multiplied by that 2x. Okay, let's see what's going on here. So to solve this one, wow, now I have a, b, and c that I need to find, and I have not only an x, but I have an x squared. So this is going to require a little bit of a different approach to how we're going to find those numerators, or those factors of the numerator. This a, I need this b, I need that c. So to start with, and I think you'll understand why, for now I'm just going to tell you what it is that you do. I'm going to go ahead and I'm going to distribute this a through both of these and this 2x through both of these. So x minus 6 remains unchanged. And then this is a times x squared plus 4 times a, plus if I multiply 2x times b times x, I would get 2 times b times x squared plus 2 times c times x. Because remember that b is a number, c is just a number, a is a number. And then what I'm going to do, and again, I think we would all agree these two are equivalent. And then I'm just going to reorder things. I'm going to use the commutative property, and I'm going to put the squared terms together. And then I'm going to put the linear term in the middle, and then I'm going to put the constant term last. So x minus 6 equals ax squared plus 2 times b times x squared. So these are my two quadratic terms. This is my linear term. This is my x to the first power. So plus 2 times c times x to the first power plus my constant term for a. So again, quadratic, linear, constant. And while I'm over here looking at this quadratic term, I'm going to factor out an x squared just because it's in common. A plus 2 times b plus 2 times c times x plus 4 times a. I'm going to set that equal to x minus 6. Okay, so why did I do this? Well, again, I think we would all agree that this and this are equivalent. I'm just kind of moving things around because what I'd like to do then, or what I notice is, if I did this, 0x squared plus 1x minus 6. Are you still in agreement with me that those two are equivalent? And I think you're going to say, yeah, I don't know what you're doing, Rogers, but sure. But look what I notice. Like, if I look at, so this is like the quadratic term, this is the linear term, this is the constant term. So let's kind of take this one step at a time. Like, do you agree then that this term right here, 4a, is going to be the same value? If these two things are equal, then that term, that constant term, is equal to this constant term. And this linear term is equal to this linear term, or its coefficients. So this is 1 times x equals 2c times x, which means 1 is equal to 2 times c. And then this is the coefficient of my quadratic term, and this is the coefficient of my quadratic term. So I can set a plus 2b equal to 0. And notice what that gets me. Okay, I'm going to, again, kind of go backwards. I always take care of the ones that are the easiest. Sometimes I may need to use a system of equations to solve it. It's why partial fraction decomposition shows up in this part of your chapter. But I think this is easy enough to do without a system. So this really is saying that c is equal to 1/2. Are you agreeing with that? If I divide both sides by 2. And a is really equal to -6/4, which is like -3/2. And then let's go through, and now I can find b because I have its value of a. -3/2 plus 2 times b equals 0, or 2 times b equals +3/2. And if I wanted to get rid of that 2 times b, I could multiply it by 1/2. Multiply it by 1/2, or think about it, dividing by 2 is like multiplying by the reciprocal. So b is equal to +3/4. So let's go ahead and write our answer. So I need to take the a factor, -3/2, and write it over 2 times x. And I'm going to have to take care of that because I don't like a fraction and a fraction, but we'll do that next. Plus, I need my b, 3/4 times x plus c over x squared plus 4. Okay. So remember before we talked about we don't like to have fractions and fractions. So I guess the way I look at, to get rid of this fraction, I would multiply it by 2. So I would need to multiply that numerator by 2 as well. So I'd have -3 over 4 times x. And what would I need to multiply this by to clear the fractions? Well, wouldn't I need to multiply everything by 4? So I need to also multiply this by 4, right? That's what I did here. I multiplied this by 2, which meant I needed to multiply this by 2, so I kept its value the same. So I'm going to do the same thing here. So if I multiply 4 times 3/4 x, that gives me 3x. And 4 times 1/2 gives me 2 over 4 times x squared plus 4. I'm not sure what that was going to be. It was not going to be an x squared, but I caught it. All right, so kind of hideous, but here we are. You can do it.